Most of us have probably been told that the rainbow goes red, orange, maybe, yellow, green, blue, purple. But it's just objectively not correct. This picture does a good job of displaying the fact that purple is not on the rainbow. It is indeed a color, but is not on the rainbow. But it still doesn't show it perfectly. If you excuse the bad drawing, I will show you exactly where this misconception comes from. So you have 3 types of cone cells. Well, almost everybody does. Long, medium, and short, or red, green, and blue. Now, red is attributed to almost exclusively long wavelengths. Green is medium, but has a pretty good range. And blue is short. So riddle me this. If you have a single wavelength at the end of your visual spectrum, why on earth would it contain red? Because purple, by definition, contains red, and so does violet. It does not contain red. Now, even Wikipedia gets this wrong. It shows red, orange, yellow, green, cyan, blue. That's all correct. Then violet. I don't think so. Now, the ancient Greeks, their oceans are cyan, especially near the coasts. This is because of sunlight, scattering, all sorts of stuff. But they rarely ever encountered blue, like actual blue, that isn't just a mix of blue and green. Cyan is not blue, just like yellow is not red. So they said cyan is blue because it was the thing that activated their blue cone cells the most. But this went into the English language, where the English word for cyan comes from the ancient Greek word for blue, which they were actually describing cyan, but they were describing it as the color of the ocean. But in most places, the ocean is blue, or at least close to blue. So that's where the misconception comes from. Now, people have been told from a young age, when they were gullible, that purple is at the end of the rainbow. And to make matters worse, a computer's blue light is about 474 nanometers, compared to 380 to 400 nanometers, which is the edge of the average person's visual perception. Some people go a little bit further. So what that means is that computers cannot represent blue in the way that it would actually appear to your eyes past 474 nanometers, and therefore cannot accurately represent those things. They can only do that by adding red and making it purple, which is just wrong. Since cone cells activating the same amount, even if it's triggered by a different wavelength, produces the same brain impulse, technically if you go past the blue sensitivity peak of your eyes, the hue can't go any further down. It can't get any bluer. It just gets darker as your sensitivity gradually trails off. Now, this is the same kind of problem as a computer, but at least your eyes don't make up red light. Your brain does. Your blue peak is 440 nanometers compared to 474 for a computer. And to make matters even worse, people will often lump in the shades of blue that actually correspond to the shortest wavelength you can see with actual shades of purple that do contain red. And the vast majority of people have been told the same misconception since they were young and gullible. So, by logic, everybody keeps saying the same thing, and therefore nobody has seen a good counter-argument. If you wanted your computer to accurately reproduce your sense of blue, you would have to make it emit 440 nanometer light, which is not usually possible for most computers, and you would have to emit it at lower intensities since the blue sensitivity trails off as your visual perception gets closer to the end. Since visual perception is different for everybody, color is subjective. But I am talking about the actual defined definitions of colors, not necessarily what people actually see. But that doesn't mean you can see actual purple instead of just a blue indigo at the end of a rainbow and not be colorblind, or have been told the same misconception so much that they've learned to lump blue at the end of the spectrum in with purple. Some people have been told that the Russian language has one word for light blue, goluboy, and one word for dark blue, sini. But this isn't exactly true, because we actually, in English, also have words for both of those colors, and it's not light blue they're referring to, it's cyan. Cyan is not blue, just like yellow is not red. So, we have a word for cyan and a word for blue, but we just don't use cyan because I guess we're dumb at this point. I'm not even afraid to say it. And anyway, if you want to call blue indigo, that's fine by me, because there's an overlap in shades of indigo that are actually just blue and don't have any red in them. In fact, all shades of indigo in real life have no red in them. It's just cameras and computers don't portray them very well. And cyan is not lighter than blue. No wavelength is objectively lighter than any other wavelength. Although I suppose if you're talking about based on the energy of one of their waves, yes. But no hue is lighter than any other hue. It's just that cyan activates more cone cells, and also when it's displayed on a computer screen, instead of just mixing the green and blue, they add them together, which is a better way of showing the color, but still it's not perfect. And English speakers often just refer to cyan as light blue, even though that's as wrong as referring to yellow as light red or pink. And if you want any more proof, look at these flowers. They are called periwinkles. Periwinkle blue is light blue. It is not purple. These flowers are the color of the sky. Yes, they are. The sky is light blue. So, there you go. But if you still think cyan is blue and navy blue is purple, then I don't know what to say.